Hello friends, welcome back to another awesome day. Day 61 of the 100 days of hell with Python algo trading. Today, we'll be learning the types of machine learning. These types are based on the amount of supervision needed for a machine learning model. So as you can see on the screen, we have basically four types. The first is supervised learning, the second is semi-supervised learning, third is reinforcement, and the fourth is unsupervised learning. So let's understand the first type, which is supervised learning. Supervised learning involves training a machine learning model based on the labeled datasets. What is the meaning of label? Let's say we have a dataset which has the data OHLCV, which we have discussed earlier, open, high, low, close, and volume, right? And these are known as the inputs and also known as the features, which we will understand in detail in upcoming videos. Then in this, we also have another column. You can say it is a, let's say, results, right? It will say that based on these values, open, high, low, close, and volume, whether the trade is profitable or it's a loss-making trade, right? So in this, we have input as well as output, and we are training our machine learning model based on both the inputs and output, right? Input is known as features and output is known as the labels. Now, once the machine learning is trained based on the historical data, this model will be able to make predictions on the new unforeseen data. Next type we have is semi-supervised machine learning, right? In which you can say it lies between the supervised and unsupervised. It uses a small amount of labeled data, which is the output, and a large amount of unlabeled data to improve the performance of machine learning model. Next we have is the reinforcement machine learning models. So in reinforcement, what happens? Let's say we are training a machine learning model on the live environment. So it will receive a feedback, which is rewards or penalties. So let's say if it is doing the task which is expected, it will receive the rewards. And let's say if it is doing the tasks which are not expected, it will receive the penalties. So based on the feedback, it will be trained on the live environment. So the last is unsupervised learning. So in unsupervised learning, what happens? We train the machine learning model based on only the features, right? There is no output, or we can say there is no labeled data. So now let's understand the types of these four types. So first of all, we have supervised. So in supervised, we have two types. The first is classification. The second is regression. So these types are based on the types of labeled data, which is output. So let's say we know that the data, we have two types. One is numerical and another is categorical. So if the data is numerical, it will be regression, and if it is categorical, it will be classification, right? So we have seen that, let's say in this column, the output, or we can say the label data, if these values are numerical values. So let's say in the results, we are taking the profit or loss percentage. So it can be, let's say 2% or 3%, 4%. So this is the numerical data. So if it is numerical in the output, then it will be the regression. And let's say if the output is categorical, right? So in categorical, what we can say, let's say we have whether it was a winning trade or a losing trade. So we can say profit, loss, profit, loss. If these are categories, then we can say it is a classification supervised machine learning model. We will understand these types in detail in upcoming videos, but for now, this is a basic difference. So when we talk about the classification, we have the algorithms like k-nearest neighbors, we have support vector machines, SVM, we have decision trees, and when we talk about regression, we have linear regression and we have logistic regression. Hopefully it is clear, because it is simply, if it is numerical, it is regression, and if it is categorical, it is classification. It is like clearly understandable, right? So the next type is semi-supervised machine learning model. So in this, we understood that it lies between the supervised machine learning and unsupervised machine learning, which means it uses a small portion of the labeled data, which is output, right? So in this machine learning model, we have deep Bell networks, we have restricted Boltzmann machines, and we'll understand it in future in upcoming videos. So we can use this in the sentiment analysis of the financial news, right? So let's say we have a news article and we can categorize a small portion of that article to, let's say, neutral, positive, or negative news. And then based on that data, we will analyze a huge amount of data. So that is the example of the semi-supervised machine learning. Okay, so next we have is the reinforcement machine learning, which is also known as the agent-based system. Okay, in which what happens, we have an agent which learns in the live environment based on the feedback, based on the rewards. So it will try to maximize its rewards. So let's say it will receive the feedback in terms of rewards and penalties, and the future decisions will be based on the rewards and penalties. For example, we can use this for an optimal trading strategies. So it will take more actions and like buying and selling, and based on those rewards, like whether it's getting more profit or loss, it will decide the future actions. It can be also used for the portfolio optimization. It can dynamically reallocate the assets based on the changing market conditions. So we'll learn this also deeply in the upcoming videos, but for now, these are just the basic understanding. Okay, and the last type is unsupervised machine learning, in which we have clustering, we have anomaly detection, we have dimensionality reduction, and we have association learning. Okay, so let's understand them one by one. So the first type is clustering. So in this, what happens, we can group a data based on their similarities, like the volatility, sector, and the trading volume. So let's say we have data and we have clustered this into multiple groups, right? Let's say one cluster is this, another is here, another is here, and another is here, right? So now we have these clusters, and by using the algorithms like the k-means, db scan, or hierarchical cluster analysis, we can segregate the data, and then based on these, we can make the predictions. It becomes really helpful and easy sometimes. Okay, next we have anomaly detection. So what is the meaning of anomaly? Anomaly means very unusual behavior. So let's say we have a trading data, right, in which we are getting like the average profit. Let's say the chart is like this, right? But on one day, what happens? The profit went very high, and suddenly it drops, and again it's on the like the normal behavior, right? But again someday it went very down. So these are the anomalies. So by using these algorithms like the one class SVM or the isolation forest, we can find the anomalies, right? And we can remove them so that we get a proper expected outputs. So the another type is dimensionality reduction. So what is the meaning of this? Okay, so first of all, let's understand what are dimensions. So we have an input and we have multiple inputs, let's say, and these are also known as the features. So by using dimensionality reduction, we try to reduce the number of features by preserving the most important information. So we'll try to reduce the number of inputs which doesn't make any difference. So even if we remove them, our output will be exactly same, right? So sometimes what happens, when we have more features or more inputs, the machine learning model becomes slower, it becomes more inefficient. So in order to reduce the cost or the time, we try to reduce the dimensions, or we try to reduce the inputs, or we can say features. So with the help of PCA, principal component analysis, or the locality linear embedding, or the TSNE, we can reduce the dimensions. So the last is association learning. In this, we try to find the interesting relationships, we try to find the patterns or the associations among the large data sets. We can use the metrics like support, confidence, and lift in this. It can be used in detecting the market regime change, or the portfolio optimization, or the different assets correlation. It can be used a lot in the HFTs. So this was the basic understanding of the types of machine learning models. So in the next session, we will move to some advanced understanding of the machine learning, and we'll try to understand all these models which are really important for us in the quant trading. So with that being said, this is it for this video. I'll see you in the next video, and until then, bye bye, take care, and have a nice day.